We're in this massive global race to build artificial general intelligence, a system that can genuinely think and learn like a human. But in all this excitement, there's this huge problem we've kind of been ignoring. How would we actually know if we've succeeded? What's the final exam for an AGI? Well, today, we're going to dig into a really different way of answering that question, getting past all the hype to find a true measure of machine intelligence.
It sounds like such a simple question, right? But it's honestly one of the hardest puzzles in all of tech. Is it about beating a grandmaster at chess? Well, we did that decades ago. Is it about acing a standardized test? Models do that for breakfast now. The entire future of this field really hinges on getting this right. So, what does a real test for general intelligence actually look like? And this right here is the disconnect at the very heart of the issue. On one hand, the big, audacious goal is an AI that could step in and do pretty much any digital job a person can. But on the other hand, the reality of how we test these things, it's all narrow, abstract puzzles that, let's be honest, have very little to do with the real world. That is a massive gap between our ambition and our yardstick.
So this puts us right in the middle of what you could call the AGI testing puzzle. We're trying to build something totally revolutionary, but we're still fumbling around trying to figure out how to even measure it properly.
Okay, so let's be super clear about what we're talking about here. When researchers talk about AGI, they don't just mean a chatbot that's good at one thing. They mean a system that's flexible, one that can juggle multiple goals, handle situations it has never, ever seen before, and actually learn from its experiences. It's meant to be a general-purpose problem solver, not just some specialized tool.
And here's the kicker. A lot of the tests we use today can be gamed. An AI can get a perfect score, not because it truly understands the problem, but because it found some clever shortcut or exploited a loophole in the test itself. It can look like a genius without actually thinking the way we'd want it to. And that leads to a really serious issue. Our benchmarks, the very things we rely on to see if we're making progress, are starting to break down. They just aren't keeping up with how unbelievably powerful these systems are getting.
So, why are our tests failing us? Well, it kind of boils down to a few key things. For one, we keep moving the goalposts. As soon as an AI masters something we thought required true intelligence, we just sort of shrug and say, oh well, I guess that wasn't real intelligence after all. We also get obsessed with the final score, and we don't pay nearly enough attention to how the AI got there. And of course, there's that nagging suspicion that these models are just memorizing and spitting back patterns from their training data instead of actually reasoning things out.
This quote just nails it. Every single time an AI crushes one of our benchmarks, we have to go back to the drawing board and question our own definition of intelligence. It's this endless reactive cycle, and it isn't getting us any closer to a stable, reliable way of knowing what these systems can actually do.
All right, so if our old benchmarks are busted and the goalposts are always on the move, where do we look for a better way? What if the answer isn't buried in some philosophy textbook, but in a much more practical field?
And this brings us to a really fascinating proposal. Forget about all the abstract debates over the nature of consciousness for a minute. What if we started evaluating AGI the same way a data scientist would test a new system before rolling it out for a real business? What if we just focused on whether it could reliably get a job done in the messy real world?
The logic here is just so simple and powerful. Before any data scientist lets a model manage a company's finances or approve insurance claims, they put it through absolute hell. A battery of tests to make sure it's robust, reliable, and isn't going to fail in some weird, unexpected way. The real question is, why aren't we applying that same pragmatic, high-stakes thinking to AGI?
Now, this data science perspective isn't just a new philosophy. It actually gives us a toolkit full of smarter, more practical tests. So let's walk through 3 of the most compelling ideas right now. First up, we have something called out-of-time testing. This is an incredibly clever way to deal with that memorization problem we just talked about. The rule is simple. You test the AI on a problem, but it's only allowed to use information that existed before humans figured out the solution. This forces the AI to actually reason its way to an answer, not just look it up online. The classic example here is Bitcoin. Imagine this. You train an AGI on the entire internet, but you cut off its knowledge right before Satoshi Nakamoto's white paper dropped in 2009. Then, you give the AGI the same exact cryptographic and economic problems Satoshi was trying to solve. Could it, all on its own, invent something like a decentralized digital currency? Now that would be a powerful demonstration of true novel problem solving.
Okay, next up is group testing. This one is all about seeing if an AI can take something it's learned in one area and apply it to a totally different one. Because think about it, real intelligence isn't stuck in a box. It's fluid, it makes connections. This test is designed to see if an AI can truly generalize its knowledge.
Here's a cool way to think about it. Imagine you train an AI on a huge library of science textbooks in English, French, and German. But you deliberately leave one out, the French biology textbook. The test is this. Can the AI use its deep knowledge of biology from the other languages and its deep knowledge of French from other subjects to generate a brand new, accurate biology textbook in French from scratch? And maybe even better, can it tell you that the textbook was missing in the first place?
And finally, there's uncertainty quantification. And honestly, this one is absolutely critical for any real-world use. It's not just about what the AI knows, it's about whether it knows what it doesn't know. A truly competent system, just like a competent person, shouldn't just make a wild guess when it's confused. It should know when to stop, ask for help, or flag a problem for a human to look at.
And here's how you could actually test this. You could give the AGI a simulated office job with a really complex instruction manual full of rules. The highest level test is a super simple prompt. Process the documents. To pass, the AI has to figure out on its own that some of those rules are going to conflict, and then it has to decide on a sensible thing to do, like ask for more information. It's a test of autonomy and responsibility, just like you'd want from any valuable employee.
So when you put all of these ideas together, out-of-time testing, group testing, and uncertainty quantification, you start to see this really fundamental shift in thinking. We're moving away from one big abstract word and towards a much more practical one.
And this is the core argument right here. It's a call to just be pragmatic, to stop chasing these philosophical ghosts and instead focus on what we can actually see and measure, demonstrations of real competence on tasks that actually matter in the real world.
So here's the bottom line. Maybe we should just stop trying to design a test for intelligence, a concept we can't even fully agree on for humans. Instead, let's pour our energy into building robust, practical tests for competence. Can the system actually do the job we need it to do, reliably and safely? At the end of the day, that's the question that really matters.
Which leaves us with a final question to chew on. As we keep pushing forward, what should the ultimate benchmark for AGI really be? Another abstract academic IQ test? Or should it be more like the world's toughest job application, designed to find not just the smartest digital mind, but the most competent and reliable one we can build? It really feels like the answer is pointing in a whole new direction.